Hello, as you know, my name is Kainton the Genius, and today I'm going to be telling you the difference between parametric and non-parametric text. But the focus of this lesson will be how to choose a particular text to use if you are given a particular problem to solve. Actually, uh, many texts can actually apply to a particular problem, but based on the problem you are trying to solve, you need to choose one particular text that fits exactly to this problem. So first, let's talk about difference between parametric and non-parametric tests, and we give examples of these tests. Remember to subscribe to my channel as a reminder. If you subscribe, you kind of motivate me to continue making these lessons, and also you get notified when I make new lessons. And I also will respond to your questions if you will leave them in the comment box below for me. Now, the two different broad categories of statistical tests, they are called parametric tests and non-parametric tests. So these two tests, they are used for hypothesis testing. So if you are having to carry out some tests or some research or some study or some data analytics, you should be able to explain what this test is all about. So let's start with the first one. Now, parametric tests are the most common tests that you always encounter more frequently than non-parametric. These are tests that don't actually that makes assumption about the distribution of the data in the population. It assumes that the data follows a normal distribution. What does it mean? So if we are talking about tests, we are trying to we take some samples and we are trying to calculate some statistics from this sample. Okay. This sample, after calculating the statistic, it's going to tell us about the population where this sample is coming from. Okay, so basically, this sample is coming from some population like this. So a normal distribution is simply means that the data follows a normal distribution, meaning that if you plot this data, is going to give you something like this. If you plot it on a graph, you have most part of the data will center around the middle with some other data at other extreme. Okay, so that's what a normal distribution is all about. So when it comes to parametric tests makes an assumption. Those tests are accurate based on the facts and the assumption that the data, the population, follows a normal distribution. So keep it in mind. Parametric tests always makes an assumption, but in the case of non-parametric tests, it makes no assumption about the distribution of the data, and that is why sometimes it's a stronger test than parametric tests. So, and if you check, non-parametric tests are actually a bit more difficult to solve or to manage than parametric tests. And that's why non-parametric tests are called distribution-free tests. As you can see from here, they are called distribution-free. So you are making no assumption. All right, so let's now take a sample problem and then we choose. I'll tell you how to choose which test to use to solve this problem. So I'm going to go to this place and I'm going to paste this problem right here. So let me see if I can increase it a bit, and hopefully it's still going to be clear. All right. So this is the problem we are now trying to solve, and we are going to choose a test to solve it. I mean, this is a very intuitive and natural problem that you may encounter in real life scenario. It says in a population, the average IQ is 100 with a standard deviation of 15. A team of scientists want to test a new medication to see if it has either positive or negative effect on intelligence, or no effect at all. A sample of 30 participants who have taken the medication has a mean of 140. Did the medication affect intelligence? All right, so at this point, let's still use the diagrams we already have to illustrate it. So in this same question, we hear about population and we also hear about sample. So this is a population. Sorry, let me take pen. So this is a population and this is our sample S. Okay. So let me draw this and then let's lay out the data we have. So average IQ of the population is 100, meaning that in the mean or average of a population is represented by mu. The average IQ is 100. Okay. We have and has a standard deviation of 15. Also, standard deviation of a population is represented um, by this. This should be of oh sorry what's the name of this symbol? Okay, it escaped my mind, but let me leave it for now. Sigma, yeah, sigma is equal to 15, and this is the average standard deviation. Also, to take note of that, take note of the fact that sigma squared is the variance, but that's not what we have. So we now have a sample of 30 participants, and in this case is equal to 30 in the case of the sample, and this is the case of the population. Okay, and then we have the mean of the sample. A sample of 30 participants have been taken and has a mean of 140. So in this case, we have a mean is represented in this way is equal to 140. So the test we are trying to do is to check if the medication affected intelligence. Anyway, that is whether it affected intelligence or not is the important thing. The important thing is we want to choose a test to do. In the next lesson, we now try to lay out the steps to solve this problem. If we scroll down on my website, remember it's kindturnthegenius.com, and you can see it in the description box below this video. You'll see that if we come here, we'll see when is z-test used. Z-test is used to test the mean of a sample against existing value. It is used when the sample size is greater than or equal to 30. Let's look at t-test. T-test is similar to the z-test. There is a typo, but in the case of t-test, the sample size may be fairly small and the variable of the population is known, or the variance of the population is known. All right, so in this case, we have a situation here that the sample size is greater than or equal to 30. So we can say it's a fairly large sample size. And the variance of the population is known. In case of t-test, actually the variance of the population is not known. So we have two ingredients in our problems. We have sample size is greater than or equal to 30, and we have variance is known. If you have two ingredients, two combinations like this, if you have these two combinations like this, then it means you should use the z-test. So if the variance is known, and of course if you are given standard deviation, it means that you also have, because this is a standard deviation, it means that you also have the variance, because we have that this is equal to variance. So the key I want you to take home from this lesson is once you have the sample size to be equal to or greater than 30 and you are given the variance, then do the z-test. So I'm going to write it boldly, z-test. So if the sample size is less than 30, very small, and the variance is not known, then we are talking about the t-test. Because these are the two confusing tests that actually you need to know among the parametric tests. I'm going to stop here. Then in the next lesson, we actually look at the procedure to actually solve this problem and find out actually the solution to this problem using real hypothesis testing procedures. I would like to thank you for viewing and also like to remind you to subscribe to my channel if you have not done so.